Hello there, it's exercise 8c. We're going to look at improper integrals today and integrating. And basically, improper integrals, as far as we're concerned, means it's a slightly dodgy integral, i.e. it goes up onto infinity, or there's some kind of asymptote in the middle of the area that we're trying to find. So it does cause us a few problems, this, if we're not careful. So let's have a look at this. Now, what's it say? It says, explain why this is an improper integral. Now, the best way of doing this is to draw the graph. So this is the graph. Now I know at the moment you haven't got a graphical calculator, but I just typed that into Desmos. I googled Desmos and found this package. It's a very useful thing. So you're welcome to do that whilst you're at home before you get the graphical calculator next year. So it says explain why this is an improper integral. And essentially it's because over here it says from 0 to infinity. Now on the face of it, it looks as if it's self-contained. But in actual fact, the graph looks more like this. It goes on forever. It does get closer and closer and closer to this line, but it never touches. So this is unbounded. So you just say here that effectively it extends to infinity. So I'd write extends to infinity. And I suppose whilst I'm writing this, I'm just going to look at the next question. It just says, now do the integration. Now the one thing I want us to do for the A-level maths is to use proper notation. So the proper notation here is to say, well, this is the limit of this. And I basically switch. The problem is the fact that it goes on to infinity. So I change it to a number, no problem. But I have to now say it's the limit as b tends to infinity. And this notation I want to see in your notes of e to the minus 3x dx. And of course you should remember that if you integrate e to the any x, you divide by that number. So it's a limit as b tends to infinity of minus a third e to the minus 3x. The power doesn't change, and that's between 0 and b. So if I chuck b in, this is the bit which what do I get? I'm going to get minus a third e to the minus 3b. But if I put 0 in, anything to the 0 is 1. So I end up with minus a third. You take away each part of it. And this bit equals a third. And this bit, at long last, I've got an expression. If I put a big number in, and try it on your calculator, put a big number into there, you'll get 0. And obviously it says minus a third, which is plus a third, and my overall answer is a third. Notice at this stage, because I've effectively put my big number in, I don't have to write the limit now. It's just it was 0. So that's my first one. Explain why this improper integral diverges. And by diverges, it means there isn't a proper answer. There isn't like a number like 4.6 that it equals. It's unbounded usually. That's the graph. I want it from 2 upwards. So effectively, I'm after this integral, but it goes on forever, a bit like the other one, and that's the issue we've got. Now again, let's do this properly. Integral from 2 to infinity, 1 over x dx. And I can't do that because of infinity, so I say it's the limit of the integral from 2 to b again, as b tends to infinity, of 1 over x dx. And now I've got a proper number in b, I can do it. It's the limit as b tends to infinity. If you integrate 1 over x, you get log x. So I shall write log x from 2 to b. Chuck these in. The limit as b tends to infinity of, well, it's log b minus log 2. Now, log 2 is a number. Log b looks as if it's not a problem, but basically, if you put a massive number in now, put a billion into this, log of a billion will still be a proper number. It doesn't disappear like the last one did. So on that basis, we say as b tends to infinity, notice the notation, log b also tends to infinity. It tends to it much slower, therefore diverges. This log b is much slower at getting to infinity, but it will get there, and that's the point. So that's that one done. Now, a couple of different kinds of questions. One we've started seeing and one we haven't yet seen. The first one is we get improper integrals when one of the numbers leads to the expression being undefined. So this is a question we're going to do in a bit, and so is this one. But they're completely different questions. This one, it's the one of the n limits, and we'll see which one it is. It says here, it says it's a problem at x equals 0, it's not defined. Whereas this one says, well, actually, it is defined at 0 and 5, but it's not at 3, and somewhere in the middle of 0 and 5 is a problem. So let's have a look at this. This is the method for doing the second one, when it's kind of in the middle of the value. And notice you end up splitting in the integral into two parts. And we'll show you that in a bit. So example, this is the one which says it's an integral from 0 to 2 of x cubed log x. And the question just now said there was a problem at 0. This is the graph. And in fairness, I really don't know what's going on down there. They have already told me there's a problem at 0, so I'm going to take their word for it. It's the integral from 0 to 2 of x cubed log x. So it looks like a by parts question. And the problem is there. So I'm going to change it. I'm going to say the limit, and I want to again pretend it's some nicer thing. So I'm going to say from b up to 2 instead. And obviously here then I'm saying b tends to 0. What we got x cubed log x dx. So this is by parts. Now you remember the late rule, and the late rule says if you have logs, that's going to be a u. So du by dx is quite simply 1 over x. My v is my x cubed. Now I'm integrating this, so when I differentiate, I've done that the wrong way around. That's my v. This is my dv by dx. My v is what I'll get when I integrate is x to the 4 over 4. So what do I get when I integrate this? It's the limit as b tends to 0. It's when you do this, you get uv. So it's uv log x times by x to the 4 over 4 minus the integral, and this times this. Alright, this is x cubed over 4 dx, and this is all of course between b and 2. So it's the limit as b tends to 0 of log x times x to the 4 over 4. And if I do integrate this, I add a power. This is just polynomial. I add a power divided by the power. I get x to the 4 over 16. That's a 16 between 2 and b. Now, can I put this in? Let's do this. We'll put the limit as b tends to 0. X 2 to the 4 then. So I put that in there. I get 16 divided by 4. I reckon that's 4. And because it's log x, it's 4 log 2. Minus 2 to the 4 is 16 over 6. I reckon that's 1. And then I have to take away, now I put b in, and that just gives me this expression, log b, b to the 4 over 4 minus b to the 4 over 16 between b and 2. Now in the question, well, I didn't point this out, but in the question it tells us when you get to the stage where that you've got the limit of some value tending to 0 of x to the k log x, you can assume it equals 0, because it's not something you'd obviously know, but that is actually what we've got here. We've got log b times by b to the 4 over 4. So that divided by 4 doesn't matter a bit. Really that tells me I can ignore that, and therefore my answer becomes 4 log 2 minus 1. I can ignore that, and this b now effectively has become 0, and that disappears as well. So I just get, so that disappears because it's 0 when I pretend b is 0. When I do this here, I'm told it's 0, and so that's my answer. So 4 log 2 minus 1, that's the posh answer. If you want to have a look at it, it may well do it better than me, who knows. And then I've got this one where I split into two parts. So I'm going to show you this one. It says the integral between 0 and 5, and I've already said the problem is on this of 3. And 3 is a problem obviously because 3 minus 3 is 0, the cube root of 0 is 0, and it's 1 divided by 0. So effectively we've got an asymptote coming down here at 3. And so what I want to do then is, if I'm going to do this, I'm going to say, well, this is the same thing as the integral from 0 to 3 of 1 over, well, it's 1 over the cube root of that. I'm going to quickly get rid of that, I think, but for now I'll write it dx plus the integral from 3 to 5 of 1 over the cube root of x minus 3 dx. So we want to make this become limits, but it's probably best if I do each part separately. So the integral from 0 to 3 of 1 over cube root of x minus 3 dx is the limit. And I suppose what I need to do, well, effectively I made the 3 now the thing that I can set equal to 0, equal to b, sorry. So it becomes the integral from 0 to b of, well, can I write x minus 3 to the power of minus a third dx? And I do that simply because it's easier then to see what it becomes. I have to add a power and divide by that new power. So if I add a power to minus a third, I get 2/3, and if I divide by that, I get 3 over 2. So I think this is the limit as b tends to 3 of 3 over 2 x minus 3 to the 2/3. There you go, between 0 and b. And if I get this now, well, if the limit as b tends to 3 of, well, it's 3 over 2, if I put b in, it's b minus 3 to the 2/3. If I put 0 in, it's actually a number, and it becomes 0 minus 3, which is obviously minus 3 to the 2/3. Now I've got written down here that that gives me the cube root of 9. Check that on your calculator. So I'm going to write, well, it becomes, it's just minus 3 over 2 cube root of 9. Oh, that's there. Now, I suppose this is the slightly dodgy thing. We've now got to make some kind of argument to say what happens to this. So again, chuck it in your calculator, put 400 in, minus 3, and you should see that as b tends to 3, b minus 3 to the 2/3, ignore the number at the front, tends to 0 again. So effectively that means I can ignore this. You get 0 if you try it. And so if I've got to do minus, is my answer a minus? Yeah, I think it is. It's minus 3 over 2 times by the cube root of 9. So that's my first part. I did say there are 2 parts. I'm going to try, I might have to pause this a bit and come back and with some working out shown. So I've just written all that out again. I've got my b written now again, my b there this time. And so when I do this integration, it's the limit as b tends to 3. It's the same answer as last time, of course. The integration's the same. The only thing that's different is my limits at the end is now b and 5. So if I do this, I still get the same thing again. That happened there. It becomes 3 over 2. Now, if I put, again, 5 in there, I reckon it's a cube root of 4 this time. So it's 3 over 2 cube root of 4 minus, and again, I think it's minus 3 over 2, b minus 3 to the 2/3. And for the same reason as last time, when I, where was it, there was the b, there was the 5 there. When I do this, this second bit disappears. So this becomes, and I don't need to write out the reason this time, it becomes that. And so my final answer is the 2 of these things together. I think the final answer is 3 over 2, the cube root of 4. I said the 2 of them added together. One of them's minus, so might as well put that second there. And I suppose that makes sense. We've got a negative bit and we've got a positive bit. That's my logic anyway. So that's the there's the posh answer. Check their answer compared to mine. And you're going to have some questions like this, so you're going to have to be able to split them. So you might want to spend a bit of time getting your head around what's happened there. So there's the answer, as I say. You're going to do exercise 8C. 8C is quite tricky, so it's certainly something we'll might need to come back to sometime next year. But best luck.